This section focuses on encrypting data at rest using the AWS Key Management Service, or AWS KMS. Protecting data at rest is important for ensuring the confidentiality and integrity of information, and it provides an extra layer of protection if your system access has been compromised. Encryption is a key method for protecting data at rest. A basic definition of encryption is the process of using a code called a cipher to turn readable data into unreadable data for another party. The cipher contains both algorithms to encrypt and to decrypt the data. A key is a series of numbers and letters the algorithm uses to encrypt and decrypt the data. Two general categories of encryption for data at rest are symmetric and asymmetric. Symmetric encryption uses the same key to encrypt and decrypt the data. This method is typically faster than asymmetric, and it's efficient for large amounts of data. Symmetric encryption is widely used and generally accepted to be secure. Symmetric encryption is a good choice if speed, cost, and low computational overhead are a priority, and you have a large amount of data to encrypt. Symmetric encryption is appropriate if the data isn't leaving the boundaries of your organization's network. Asymmetric encryption uses both a public key and a private key, a key pair, to encrypt and decrypt the data. A file is encrypted with a public key and can only be decrypted by a private key associated with that public key. Asymmetric encryption is generally regarded to be more secure than symmetric encryption, but it's much slower. Choose asymmetric encryption if you have to share data outside of the organization or have regulatory or non-repudiation requirements. Envelope encryption is not an encryption method like symmetric or asymmetric, but it's the practice of encrypting the key that you use to encrypt your data. An analogy is locking your valuables in a safe and then protecting your safe key by locking that in your safety deposit box at the bank. You could continue to add layers to this, locking each key in a subsequent secure location. The steps to use envelope encryption are to first encrypt the item with a key. This is your data key. Then you wrap that key with another key, the key encryption key, and keep on going for as many layers as you want. You store the encrypted key with the encrypted item. You can apply encryption on the client side, CSE, or on the server side, SSE, or you could use both. The approaches are not mutually exclusive, and of course, they're based on your use case. With CSE, your application encrypts data before sending it to AWS. You create and manage your own keys, and the keys and encryption method are known only to you. With SSE, AWS encrypts data on your behalf before writing it to disk, and then decrypts it when you request to access it. The keys can be managed by AWS. Here's an illustration of the concepts we just discussed. Encryption software running in the corporate data center encrypts data with the key before uploading it to an Amazon S3 bucket. In this server-side example, you upload the unencrypted data over HTTPS to Amazon S3. Amazon S3 encrypts the data using AWS KMS before storing it. The service endpoint handles the encryption and decryption. AWS KMS is a managed service that provides the ability to create and control keys for encrypting data. You can automatically rotate keys on a schedule and disable or delete keys. You can also import your own keys instead of using AWS-generated keys. You can manage your own keys in AWS KMS or use AWS KMS managed keys, and you can use either symmetric or asymmetric encryption. You can use cryptographic operations, which are API calls that use AWS KMS keys to protect data. Options include encrypt, decrypt, generate data key, and generate data key pair. These are described in more detail in your student guide. Many AWS services use AWS KMS to support data encryption, and a complete list is linked on the Content Resources page of your course. These integrations use only symmetric encryption. Two important storage services that integrate with AWS KMS are Amazon S3 and Amazon Elastic Block Store, or Amazon EBS. Let's walk through an example with Amazon S3. When you choose server-side encryption with AWS KMS, called SSE KMS, AWS KMS and Amazon S3 perform envelope encryption as part of encrypting your data. When you upload a file, Amazon S3 requests a data key and a copy of the key encrypted under the specific AWS KMS key. In this example, it's a customer-managed key. AWS KMS generates a plain text data key and encrypts it under the AWS KMS key and sends both the data key and the encrypted key back to Amazon S3. Amazon S3 encrypts the object by using the plaintext data key, stores the object, and then deletes the plaintext data key. The encrypted key is kept in the object metadata. When you request the encrypted object from Amazon S3 sends the encrypted data key to AWS KMS in a decrypt request. AWS KMS decrypts the encrypted data key by using the same AWS KMS key, and it returns the plaintext data key to Amazon S3. Amazon S3 decrypts the encrypted object using the plaintext data key, and then it removes the plaintext data key from memory as soon as possible. Your student guide also includes a walkthrough of a similar process for Amazon EBS. Here are the key things to remember from this section. Encrypting data at rest makes it more difficult for attackers to compromise data. Symmetric encryption uses the same key to encrypt and decrypt the data, while asymmetric encryption uses a key pair, a public key for encryption and a private key for decryption. Envelope encryption is the practice of encrypting plain text data with a data key and then encrypting the data key under another key. With CSE, your applications encrypt data locally before submitting it to AWS and decrypt data after receiving it from AWS. With SSE, data is encrypted at its destination by the application or service that receives it. AWS KMS keys are the primary resource in AWS KMS. Use an AWS KMS key to encrypt, decrypt, and re-encrypt data.